Hello everyone. We are back now. Let me share my screen. Yeah, and let me see if it works. Can you see my screen again? Great, thank you. Right. So we were continuing working with our NumPy array. So the next thing that I wanted to cover before the break was another option on the arrays, and that is, let me just change my tab on here, and let me go to the training material and scroll down to this nice figure that you have we have in here, this one. So NumPy arrays allow you to define where do you want to perform a certain operation. So the way it works is that you can provide an axis option, and that means that the operation will be performed along that axis. So, for example, and here in the figure on the left side, we are working with calculating the maximum value on the data array using axis 1, meaning this will be done on the columns. Sorry, this will be performed over the rows. While if you were to provide axis equals 0, this will work over the columns. Actually, let us try to do that first. Let's try to do this. Let me just go back to my notebook and let's try doing this. So let us try print numpy dot min value data axis quotes and lag 0. And so I'm asking to calculate the mean value of data over axis 0. That is well, they give us this value, but it's a bit long, so I'm not sure. I'm unsure about how many elements that they have. So let me repeat the command. So I just will modify the cell that I just wrote, and I will add a dot. So, and I can do this because the output of this function here, the output of this is a specific data type, and that data type has is an array itself, and for that reason I can access its shape. That must be a bit confusing because I'm not assigning this to any variable, but the Python allows you to do that as long as the result of this operation is a specific kind of data type. In this case, an array. You can access operations or functions specific for that kind of data type. So in this case, shape is a specific function that arrays have. So let me just do this, and tell me that the result has 40 elements. So meaning that this was applied over the this is daily we have 40 days in our data, so we have 60 patients and 40 days. So this means that when we use axis 0, we actually calculated mean value for every day, and what we have on this result was what we were showing before was the mean value for all patients and the daily mean value for all patients. So I hope that makes sense. If not, please put it in the chat. If I need to elaborate a bit on this, we can do something similar using the other axis, like print numpy.mean and then do data. And now I want to use the other axis, axis 1, shape. And if I do this, it says that after executing this operation in here, the result has 60 entries, meaning that the mean value that was calculated in this cell was the inflammation, the average the mean inflammation value for every patient. So that's how you can apply operations on the specific axes on your arrays. So hopefully that makes sense. If you want to see the actual content, not that content, this content, print numpy dot mean. You just need to drop the dot shape option and just hit enter, and you will see those 60 entries in here. Right. Now, let us, probably, there are a few examples and exercises on the training material that you can probably take a look at yourselves after this course. It involves working a bit about how to slice strings and a bit about working with arrays. But for now, let me move on. Just try to cover more material in this training session. And I will try to now show you how to visualize data. This is something that is very useful. And again, it's something that might work differently depending on how you are working with Python. So on Jupyter Notebook, this is fairly simple. As long as you have the proper libraries installed. So in this case, I need this matplotlib. That is it's a library in Python that specializes on plotting functionality. And specifically, there is a subset of functions that you can access through pyplot. So if I import this and I define an image, matplotlib.pyplot, that one, and I want to do a specific function, matplotlib.pyplot show. Hopefully you will see something similar to what I'm how to show. So it takes a bit of time, but Python goes ahead and it plots the data from my data array. You can see here that it's plotting something similar to a heat map. In this case, the low values are represented with the blue pixels, and yellow pixels are representing high values. So it seems like inflammation is higher on the close to the middle days, and it's more or less the trend is similar across all patients. Have, are you able to see this image in your own setup? If not, then maybe something else that might be needed. Maybe the library, or maybe in the terminal you cannot see it by default. Please let us know. Okay. As I said before, you can do you can work with specific. You can slice your data, or you can extract. You can perform the operations in a specific axis. So, for example, if I wanted to know the average inflammation, yes, how do you interpret the heat map? So let me just answer the question. So this heat map is, so you have 60 entries, 60 levels or rows in here. So on the y-axis, you have 60 elements. Those are the patients. If you remember, we have 60 patients, and we have the measurements for their inflammation data over 40 days. So this will correspond to 60 patients on the y-axis, or the rows, and 40 days on the x-axis, or columns. So what this map is showing us is that so the blue colors are the low values, and the yellow colors are the high values. So it seems like our patients are experiencing more inflammation closer to the middle of our recording period. That seems to be the case. So we will be trying to extract more information using plots to try to further understand what is happening. So if I wanted to calculate what is the average inflammation, and the numpy mean, we were using this before to extract the mean value of an array, but I want to calculate the mean value in a specific axis. So I want a specific value over our columns. So if I do this, now average inflammation will be holding the average value for every day. Now, what if I want to plot those values? So what I do is I do matplotlib, I do pyplot, and then I do plot, and I tell just plot my information there, and I ask matplotlib to show it. And there. Sure. And if I execute these three commands, you can execute one by one, or three on the cell, and you should get the same result. Python goes ahead and it prints this figure, and it sort of what it means is we have here the average inflammation per day because you have 40 entries here on the x-axis across all patients. And it sort of makes sense with what we saw before, because we saw that the yellow values corresponded to the high value. So here, this average value per day seems to make sense in that regard. So what happens? I mentioned before, we assign the average value, the array holding the data to this variable average information, and then we asked Pyplot to create a plot in here using average information as input, and then we asked Matplotlib to show it. So something up that, if we are more familiar with how these kind of results actually work in reality, is that you might not be expecting to see a linear rise and fall. That might trigger some bells, but we should probably carry on trying to gather more statistics to try to further understand what is happening. So let's try to do the same now, but now instead of the average, let us try to plot the maximum values. Max plot. So yes, I'll just show you how to do that. Well, in a few comments down. So what in math? Let me just first prepare some figures, and then I'll show you how to save them. I just want in this occasion, what I want to show you is that you don't actually need to define a variable holding the data. You can just perform the operation directly in here. If that's something that you prefer, just because you don't want to, that extra variable in your environment. And then you call Matplotlib pyplot, and that show. And if you do this, hopefully, so this is telling us that we're just asking Matplotlib to create figure using the output from this command as input, and then asking Matplotlib to show it. So this is calculating the maximum value for all patients, the daily maximum value for all patients. So again, you can see that something odd is happening. So let us do the same with the minimum values. So let me just copy my previous command, and I will just copy it in here. Just copy that one. I need to modify it, so I will be doing that. So maximum, I will change that to minimum, and then I need to change also this function in here, numpy.min, but everything else is the same. And now I need to do matplot again, the same matplotlib to show the figure. So show, and execute this. Now we have a couple of new figures. So we have the maximum values per day and the minimum values per day. So what we can see here is the maximum value rises and falls smoothly, while the minimum seems to be a step function. And well, neither of those seems like to be particularly likely. So there might be something odd happening. There might be a mistake somewhere. But we just realized this because we are able to see this as figures. Without that insight, it might have been more difficult. So it's very useful for you to being able to analyze your data quickly using Python like this. So hopefully it's something that you can find use in the future. So the figure, the next question was about how to save these figures. So so that's a good question, and it's very useful to be able to save figures. So on the training material, there is a script to do this. So you could just go to training material and copy that script, and I will be trying to just go step by step. But feel free to go to the training material and copy it directly if you don't want to type as much. There is a question for Pablo. It says that from the plotting perspective, is there any advantage of using matplotlib or pandas over using R? Huh. I would probably be biased because I don't have a lot of experience using R. I have more experience using Python, and it's just preference, I suppose. I don't know if one has more experience with R that could comment. But from my point of view, I think they're very similar. So depending really what kind of data you're working. If you're working specifically with statistical data, you might find R that is just suitable. I like pandas because I like Python because it has a lot of other nice features, and you can extend the functionality fairly easily. But yeah, again, might be biased. So I will continue. So I will be writing many of these commands are already been executed. So in principle, I could just not type them, but just want you to show you how you will be typing a full script to produce the data that you to import data, to accommodate a nice figure, a nice setup, and actually plot it and save it. So how this will work in the real life is that you will need to do matplotlib. You import the library that you need first. Typically, importing libraries go at the top of the script. So I do this, and then I start executing the commands. So in this case, numpy dot load text. Again, we have do this already in the past, but for the sake of showing how it is done. So we will be creating figures for only the first that data file. Now what I'm doing is, so first I imported the data and save it into, imported the data file and save it into a variable called data. Now I am using a new command that we haven't seen before, and this one is a figure function from pyplot, and I explain in a moment what it's doing. So what this figure command does is that it creates a space, like a canvas, where we're going to be placing our plots, and it takes two arguments. It takes we need to tell how big we want this space to be. So it is basically two coordinates. It is how high. No, sorry. So how the width first and the height later in second term. So it will be 10 units on the x-axis and 3 units on the y-axis. You will see how that works in a moment, and that probably will make more sense. But we are saving that space on a variable called figure. So that figure will be holding our plotting space. So now what we are doing is, I'll explain this in a moment. Let me just first write it. So what this means, figure, the space that we have, that we just have defined, has a few functions that let you interact with that plotting space. So one of those functions lets you add subplots into the plotting space. So this is the name of this function, so it's subplot, and you access it through the space that you just defined. So, and the arguments that it takes three parameters. So the first one defines how many total rows there are in our plotting space. The second one tells us how many total columns, and the last one is telling us in which order, in which place is going to be our current subplot. So we're basically saying is this subplot that we are adding here will be within a space that it has 1 row and 3 columns, and will be occupying the first place. And we are assigning this subplot to another variable called axis1. And we will be doing the same for 2 more subplots. So let me just copy this, and this will be axis2, and this one will be in the same plotting space. So that's why I will be leaving 1 and 3 unchanged, but it will be occupying the second position. Now, because it has my plotting space has three subplots, 3 spaces, I will be adding one more. So, and this one will find the 3rd space. So that's it. And now that I have my subplots defined, what I need to do is to actually tell Python what is going to be the content of those subplots. So what I need to do is access 1. So that's how I interact with the subplot. And then to set y label, we do average. That lets me tell that the label for my first subplot will be this average. Access 1 dot. And what I actually want to plot in here is the result of executing the min numpy function in the data array over the axis 0, as we saw before. And we do something similar with the other axis. Let me just go back here. Axis 2 dot plot numpy. No, let me just first define this label. And I do this one will be the max figure, and there. And well, the content for this plot will be numpy dot max data axis 0, axis, and then last subplot that is set y label, first label. That doesn't need to be in that order, just for readability. Axis 3 dot plot, and define the content, and point dot mean data axis 0. So this is what we have done so far. And so now there is another option. It's optional that lets you define a bit about how the final plot will look like, and the effect of this option will be evident once we start comparing what happens if I remove it. So for now, just let me define it, and later I will show you what happens. So if I remove it. So finally, we just created space. We created a space to plot our figures, created a different subplots that plotting space will contain, and define the different options for every subplot, including the labels and what is the actual data that those plots will contain. So now let me actually do the plotting. Plot. But before I'll be saving, and this is how Dinesh, this is how the command that actually saves the figure. So this save figure from the PyPlot library is the one that lets you yes, and Python lets you work with different formats. You can do, not sure if you can do TIFF. You can try, see what can work. It definitely can work with PNG, JPG, and SVG. So I have worked with those before. Not sure about TIFF, but we can try it. And then if I want to see that is plot right now, just type show, and hopefully let's see how many typos I did. Yeah, let's see. There's a typo in here somewhere, and yes, here. And that's one solved. That's another one. Layout. Yes, layout. That's how you write layout. And now, say figure. Matplot is not defined. Of course, it's not defined because it's matplotlib. And now, there you go. So you have three nice figures. And so yes, this is what I was meaning. I was referring to when I said that you will have a plotting space with with 10 units, width and 3 by 3 height, and you have when we were adding the subplots on the plotting space, we said that we only have one row, that is this row, and three columns. So this is how it's sorted. Now let me show you what was the effect of this figure dot type layout. So let me just remove it and show it. So I'll take a bit of time. And I don't know if you notice, it might be better in your if you're doing this locally. But if you look closely, you will see that this labels max is closer to the edge of the previous plot. Here, I think in the max one is more evident. Let me just activate this function again. You will see now the max has a bit more separation between the previous plot. So it's very subtle. That's the impact. So the figure type layout sort of lets Python or pyplot decide how best to accommodate the plots, um, uh, assuming that it's going to be, the space is limited. So right, I don't know if you have any doubts. And if you realize, we just created a script that you can reuse for in your own work. So it has everything that you need. So the correct product script, Shashin says where it is located. You can find it in the training material. So in here, let me just change my tab, and I'll scroll down and access the next lesson. And it's under visualizing tabular data. So if you scroll down, you can see everything that we have done so far. And in here you can find this script, so with all the instructions, and you can just modify it to fit your own, to load your own data set, and you can do the plotting yourself. Sure. Let me just copy this and put it in the chat. There you go. Let me go back to the chat. Where's the chat? There. Okay. Right. So let me go back here. Yeah. So question that you might have is where it was saved. So by default, it should be saved and where you're executing this script. So if I go back, since I am Jupyter Notebooks, it will be easier to visualize on my first tab, and I should have now something called PNG. I might need to reload. Let me see if that works. And I know I'm in code. No, sorry, I should be on data. I jump to data. Here's it. So this one is the one that you just created, and you can see here that it was created 4 minutes ago. So that's how you how to check where it is. Or if you're in a terminal, you can just list the content, or if you are on Windows, you can just open the your Explorer, your Direct Explorer. And all right, now what else? There are a few exercises in your in the training material that let you play with a few more options, like how to define the scaling for your plots, how to draw some straight lines, and how to further modify the plot. But I just want to demonstrate what would happen if you wanted, for example, to can you show once? Yeah, no problem. Dinesh is asking me where it was saved. So I went back to my first tab. So in here, so because I am working from in this directory on data. So that's the directory where I'm currently executing all my commands. It was saving here. And you can see it there. But this really depends where you are actually located. On Jupyter Notebooks, I think you can interact a bit with the underlying terminal. if you do something like this, let me just see if this works. Um, so this exclamation symbol tells Jupyter Notebook so that what comes after it, it's not a Python command. It is well, in this case a bash command. Uh, so don't be surprised if it doesn't work in your system. Might not necessarily might work. I haven't tested on Windows, but you can try, and they will let you know where you are currently located. But please tread carefully. um, so let me just demonstrate one more way to modify this script. So say that you wanted, instead of having all the different figures plotted side by side, you want all of them plotted one on top of the other. So this is an exercise, not training material, but it's just might be useful to show it in here. So if I wanted to put all of them one on top of the other, you will need to modify the plotting space, and for that you will need to first change how this how I define it here to make it taller. So if I just swap these definitions, but now I will be having 3 rows instead of only one, so and only one column, and yeah, and hopefully that might work. And yeah, seems like it worked. And you can modify the display how you know this each plot is how the weight of every plot. For example, if I want maybe like this to make it a bit wider. But yeah, there are a few examples, a few exercises in the training material that you can go through them and learn a bit more about what commands are available. For now, let me just carry on and start actually looking at loops. Loops are very useful. Um, so it would be, so let me just start with something relatively simple. Let us define a word. And the training material is like this: word let. So if you do that, then now word has this string stored, and you can access the different elements like this. Yep, as if it were an array. You can access like that, and you can access every element. Oh, let me just copy this, and and I was just changing. I want to access element 0, element 2, element 3. And if you execute this, it will print the whole word. That's good. That works. However, obviously, you can already see what are the problems with this approach is that it's not scalable. Like, what if the word has hundreds of elements? It's difficult to maintain. Yes. What if I wanted to modify, do some modification to every word? Make it, I don't know, add some other symbol, decorate it in some way. I will need to do it for every character, and depending on how many there are, might be difficult. It is fragile. What happens if I have more characters or less characters? So if I have more, like if we were typing oxygen, and I do this now, it will not print the whole world, the whole world. Um, or worst, if it has less characters, the word is shorter. Do this. I actually cause an error because now it's trying to access. I'm trying to access an undefined position, and yeah, it's telling me that I'm out of the range. A better way to do it is let's just redefine again. Is to use a for loop. So for loops on Python are created like this. So you use a keyword called for, and depending on which interface you're using, it might help you with how to using colors. So you saw just so that I was typing for and it just colored a screen. So it is that's Python or Jupyter Notebook's way to tell me that for is a special word. And then use a variable. It could be anything in a list of things. In this case, this variable is holding a list of characters, chars. Then a column. This is part of the grammar. So, so now if I hit enter here, you see that it brings me not to the beginning of the line, but somewhere further. It's indented. That's not a mistake. That's on purpose, and I just explain in a moment what happens. So print char. So let me just do this, and if I execute this, you see that it works. It prints every single character in that word. So what happens is I just define the loop, the for loop. As explained, you use a keyword for a variable that is important to mention. It could be anything. It could be called just C. As long as you're consistent in the loop, meaning you are using the same character or same variable name, it will do exactly the same. And then in is another keyword, part of the grammar for the for loop, and then a list of things. It can be a variable that contains a list of things, or it could be a specific list of things. Like for example, if I now instead of if instead of using the variable word I do oxygen, this is still a list of things, a list of characters. If I execute this, you see now that I'm looping through this list now. Every single character on this list. So there are two ways to do it. You can either use the specific list, and as I'm doing here, or you can use a variable holding a list. Right. So the indentation is another tricky one. So if I weren't to this colon at the end, if I don't put that colon, that's I have done that mistake several times. Sometimes the program will let you know, Python or Jupyter Notebooks, or depending on which interface you're using. Sometimes it will let you know when you hit enter, and it will bring you right to the beginning of the next line because it didn't understand what you're trying to do. So it won't work as you expect, and you will see something like this error. It's saying this invalid syntax. So you need that colon, and that colon allows you, to have automatic indentation, depending on your platform or the way you're interacting with Python. But typically, it might include those spaces automatically for you. anything that is indented after the for, this for word, anything that comes indented, it will be part of the for loop. This is different from other programming languages like C or Fortran that have a specific ways to closing for loops. Python, the way to tell Python that you finished with the for loop is to come back to the beginning of the line, and that way whatever comes after here, echo. No, sorry, that's bash. Print and part of the for loop. Yep. If I execute this, you see that this print statement is executed every time, but the last one is not. If I were to make it put an indentation before it, it will be executed every time. So that's something for you to keep in mind. For now, let us leave it like this. So hopefully that was not too difficult introduction to for loops. There is some nice descriptions on the training material if you want to take a look about how is this for loop exactly operating. There's a diagram that lets you sort of see visually. Let me just change into that. Show the image. That will show you how the for loop is working. So in this case, you have a variable called char and a list, a variable that is holding a list of letters called oxygen. So in every iteration, the variable is changing its value, and it's printing that value. So the first iteration, the variable has the letter O. The second iteration, the letter X, and so on until it reaches the final iteration, that in this case is 6. So hopefully that's clear. If not, please let me know in the chat. Try to expand a bit on it. Right. We can use for loops to update variables. For example, if I want to know how many elements there are on the list that I'm looking through, I could do it like this. And I obviously here I forgot the column, so I'm in the beginning of the line. There is no indentation here. Plus 1. And then I want to finish the loop here, so I go back to the first, the beginning of the line. So print, and then just there are and I execute this, telling me that there are 5 vowels. So what it's doing here is that I start my length variable. I assign the value 0 at the beginning, and then during the loop, I iterate through these different letters, and every time I perform an iteration, I update my variable length. So initially, it has the value 0. After the this iteration, vowel has the value A, but length initially had 0, and then I add 1 to that value. That's the end of the first iteration. In the second iteration, I access vowel has the value e, and length has a value of 1, and I add 1. Then now at the end of the second iteration, length has a value of 2, and so on until I reach the letter U, and which point length had the value 4, and I add 1, and ends with the value of 5. That is what I am printing at the end. So that's more or less, you can keep track, for example, of how a variable is changing, or you want to update some variable within a for loop. That's one way to do it. Another thing that might be confusing is that it's different in some ways to how other programming languages work, in the sense that the variable that you're using for a for loop, let's say for letter in ABC, print letter, and then let me just print after the loop letter is letter. So if I do this, you can see that this variable was defined within a for loop. If you're coming from a C or C++ background, you might find this surprising, since typically variables that are used as indexes on for loops or any other loops doesn't exist after the loop finishes. In case of Python, they do. And even if I define it previously with a different value, letter equals, you can see that still the letter is used on the for loop, and its value is updated, and it remains like that after the loop finishes. So something to have in mind. Again, can be confusing. If you're a new user, this should be, this can be straightforward, and you might think, oh, that this is how it works in the programming language. It's not. There are some different programming languages have different ways on how loops are performed. So something to have in mind. What you did before, a couple of commands back, was to try to calculate the length of a list of items, in this case letters. You don't need a for loop to do that. You can actually just use a special function, Python function, that is called length, short for length, I suppose, and just provide the list of items for which you want the length. In this case, if I execute this, it will give me the same options. It's way shorter, way faster, and just give me exactly the same output. Not very useful piece of a command tool that is used in the for loops is something that I call range. So typically, you might want to iterate over a certain number of items, and to do that, you can define a range of items. So, for example, let me show you quickly. So for number in, I will be using here the keyword that is, well, the command that is range. And here I will define, it can take 1, 2, or 3 arguments. So let me start with only 1 argument. Let me start with 3. And let me, yes, print number. number. And by default, if you only provide one argument to range, it will give you a list from 0 to the number that you provided. Range can also take 2 arguments. For example, if you give from 2 and 5, what this does is 2, 3, and 5, 2, 3, and 4. So basically, it starts at the first argument, the number provided in the first argument, and it stops one before the second argument. So in this case, if I provide 2 to 5, it's a list of 3 items, and that runs from 2, 3, and 4. And last, it can accept 3 arguments. And so, for example, if I were to do something like this, so this is how it works. So what it does is that in this case, range, what it does is it starts at the first argument, as before, and it stops before the last argument is reached, but it advances using the last argument as a step. So it will be advancing two units at a time. So 3, 5, 7, and 9, and it stops there because the next one, 11, is beyond the limit that we provided in here. So that's very useful when working with in for loops. Okay. As before, there are a few exercises on the training material that I think could be useful for you to look through and do after this training has finished. We'll explore a bit more on how to work with for loops and using range. And the solutions are also provided in the training material, so feel free to check those exercises. So let me now move on to how to work with storing multiple values in lists. So we have done a bit of that so far, but now let me just expand a bit more on this. So let me define a new list. So that list is defined by using square brackets. You might remember that we saw square brackets when we were using NumPy arrays. So it's somehow related. But for now, let us just say that a list is defined by using square brackets. So in this case, I will create a list that has some odd numbers. So 4 odd numbers. And I will print odds are odds, and it does as we expect. So prints the message and prints the list. Now, but let us try to access those elements. So before we were accessing, for example, the specific letters in a word by using the square brackets. So this is very similar, and you can think of a word as a list of characters. That's why you can access those specific letters in the same way. So odds, if I execute this, it will tell me the first element. I am accessing the first element that is 0, and its value is 1. And I can do the same. Now, if I just copy this, and I want, for example, the last element, I can do, because I know it's 0, 1, 2, and 3, I can just ask for item 3. And this will work. It will bring me the last item. But there is an alternative way in which you can access elements on a list. So just copy again, paste. Again, I want to access the last element, but this time, instead of using a 3, I will use a negative number. And you can see that the output is the same. So this is an alternative way to do it. And it's very useful, for example, when you don't know how many elements there are in your list. So I could change my odds list to, have, I don't know, more elements. And if I don't update my this statements in here, I will still be printing by using this statement, odds 3, I will still be printing 7. But my last statement will actually be printing the last element, because this is the negative number starts counting from the end of the list to the beginning. Thank you, Pablo, for joining. Hope to see you tomorrow. Now, all right. Now there is a confusion sometimes when trying to work with lists, and it's something that might be problematic for depending on your programming background to get your head around, and is the mutability of things on Python. And that is, say that I have a list of names. Now just there. And I will introduce a typo on purpose, and then during, and so if I do print names regionally, any of the typos are not intentional. Names, and I do now names 1. I want to print the first element on here on that list, and say that I want to change it. Print, and I want to do final value of names. So what is the new value of the list after I change one element? So if I execute this, and yeah, there is a type. Struggling with a bit, sorry. So so originally I print first my original list with the typo, and then I go ahead and redefine the first element on that list to correct the typo, and that worked. That's fine. However, if I had this kind of list instead, this is a list of characters, and we saw that we can actually iterate through it, and we can actually access every element as we do in a list. However, it's not entirely similar. Like, for example, if I wanted to change the capitalization of the first letter, I wouldn't be able to do this. And it will throw an error, and it will tell me you cannot change that item. So, so the string object, so this object in here, does not support item assignment. So this is Python way of telling me that not all data types on Python support are immutable. So strings are one of those items, and also variables like floats and numbers. So you can, if you wanted to change it, if you wanted to change this variable, we cannot access, and we cannot change just one element. We will need to redefine it entirely, as we would do with integers and floats. And in this way, it will work. So let me just comment out this. Now print name. And that way it works because I just redefined the whole variable. Just something to have in mind when you're working with lists. Right. Another curious behavior of lists on Python is, for example, let me just, I will create another list of how to prepare salsa. Onions, you need to use peppers, onions, some cilantro. Why not coriander? Tomatoes, and this is my list, right? Now, I want to save this list as my salsa now. And for those of you who come from a different programming language, you might think you're actually making a copy, but you will see in a moment that that's not the case. So, okay, so I saved my salsa with the previous content, supposedly, and now I will change the content of the first element of my original list. So, hot peppers, print. And I want to now check what is the content that my salsa has now. Ingredients in my salsa. And I'll just print my salsa. And if I do this, you can see that I was originally intending to use hot peppers, but now it seems like I'm using them. So what happened is that on this statement, I'm not actually creating a copy. I am what Python is doing is pointing my salsa to the same place in memory as salsa was storing its original contents. So this is probably don't want to go into much detail about memory things, but just something that you should have in mind when working with lists and you want to change them. You should be aware if any other list might be pointing to the same list somewhere else in the program, because this kind of errors might be sometimes tricky to detect and to debug. So what if you actually want to make a copy? So the way to do that is to use something like this. So in this case, I'm saying I want to get a new list based on salsa. So in this case, now, if I execute this, you see that now my salsa now has the original content. And if I were to print salsa, that it will have the new hot peppers instead. So that's something that can be difficult to sometimes understand, and even more difficult to get used to. But as long as you're aware of it, you can try to spot when those errors might happen. What else could be good for me to show you is probably that a list on Python doesn't need to have the same elements, the same data types. So, for example, ages. So in C or C++, if you create a list, it will either be a list of integers or floats or strings, but you cannot combine. On Python, you can actually combine, and this will work perfectly. There's no problem. And if I were to print this, so it will show me the content, and that's okay. You can work with if you want to modify a list. Let me just work with my previous list that I was working with. I defined this in the past, so it had this content 1, 3, 5, and 7. If I want to add more elements to this list, say that I want I want to add 11 to this list, I can use one of the functions of list, and it has several. Again, if you do the dot, use the dot and use tab, you can see all the different functions that it has. I want to do append, that is one of the functions, and if I do this and I print now the content, that you see that now I have a new element on my list. So that's one way to do it. I can also remove elements. So if I do remove element, and I do now auth dot pop, and I want the elements from that list, and I do print. Let me just put auth print remove element. You see here that after removing the element, auth doesn't have the 1 at the beginning, and remove element have now that element. So again, if you want to find more about how a specific function works, you can use this command here, and it will let you know. Hopefully, it will display to you how the function is supposed to work. Right. Probably I should be trying to show now. Might be worth stopping here about lists and just show you something that might be more useful for future examples. Is that how to analyze multiple files. So what I will do, what we did before was to create a script to plot to save 3 plots on one figure. So what I will try to do now is to create the same script, use the same script, just that now instead of applying only to one data file, I will try to apply to all the data files that we have. So if you remember, I only was working with inflammation -01.csv, but there are many others. We have 12 of those. So what if I want to do those 12 and maybe more than might be, I might receive more data files and I need to process them as well. So I might want to run a script that is able to process all of them. So I can do this with another Python function. It's called import glob. So let me just show you how this works. So glob. Uh, so what this glob function, this glob library allows me to do is to use wildcards. Now, if I do this, now this wildcard actually lets me have visibility of all the different files that I have in my directory, and that's useful. So if I were to, let me just scroll up and copy the file, the script that I had before. If you remember, we just created this script. I will just copy it. And bring it down here. And I will do the modifications necessary to work with all my different files. So I will add my library glob. And now I need to define my file names. Okay. And this is not a function that we have seen before, but basically sorted will get the list that I got here, and it will just sort the list. And we'll do information, and I will use the wildcard to refer to all the files in my current directory. If you have the files in a different directory, you will need to use a relative path. And so close this. And I can work with all of them, but just for demonstration purposes, I'll just work with a subset for now. And I do 3. Just want the first three files, so 0, 1, and 2. And then, since this is a list of the different files, what I will probably need to do is to execute all of these instructions within a for loop. So, because we need to execute to create a new graph for every single of those files. So, what we need is actually a for loop for file name. That's my variable in a list of things, and in this case, it's the list of my file names. Then the column, and I start. Let me just print the current file name, just that I have visibility on what it's doing. And then I start adding the different instructions. So I can just reuse the ones I had, but I need to add the indentation, so that to specify that this will be part of the for loop. And I need to change this now. File name, and now everything. The last thing I did was to work with changing the size, but let me just go back to how it was before, only one row, and also here I define the subplots, and again I just want one row, and struggle with the lag again. There we go, and 3 columns, and everything else seems to be similar, and I don't need to modify it, so it should be okay. Just need to add an indentation to make it part of the for loop. and I could save the figure, but let me just not do it right now because I will need to update this name differently. But I just for the sake of demonstrating this, let me just comment this out and just show the figure how it works. So hopefully let us see how many typos I had this time. Not many, not none actually. And yeah, that seems to work. So it is processing every file. So information 01, information 02, information 03, and it stops there because I just asked for a subset of the files on my list of file names. But I could just go ahead and use all of them. But you see that that would be probably the best, not the best, but that's one suitable way to start working to develop a script, a Python script for you to work. So you start developing your script for one file in the file that you need to analyze, and then when that works, you and apply that script for more files. Probably you will be using a for loop in that case. So hopefully this will be useful for you. And I think we only have 3 more minutes on the session, so maybe might be a good moment to see if there are any questions that you might have. There are more material available on the website that you can go through it. And I think next week there might be another Python course. I don't know if Juan wants to mention anything about that, but if not, please feel free to go through the remaining training material. Hopefully what we have covered today it will facilitate things in terms of understanding what the remaining. And yeah, I mean, it was very good session, and thank you for joining. And please let us know if you have any questions. Yes, it can be problematic. Regulating, yes, right. Yeah, Dinesh has a question about working with Jupyter notebooks on Windows. Apparently, there is no. At least the default is not to show the documents as in your home directory as in Windows, as in Linux and Mac. There must be a way, but unfortunately, I'm not. I tend to work with Linux and Macs, so yeah, sorry about that. Probably I need to get some test environment in Windows. So if there are not any other questions, well, thank you very much for joining, and hope you enjoyed this session, and we will see you tomorrow.